All right, today we're going to look at some problems from section 4.5 in our textbook. We're going to find the roots or the zeros, or at times the directions, or solve the equation when it's equal to 0. So all of these things mean the same thing in terms of what we're going to be doing and finding in our strategy. So we're going to first look at f of x equals x cubed minus 5x squared minus 4x plus 20. We're going to find the roots or the zeros. So we're going to set it equal to 0. So you see that this is exactly the same problem as saying solve that equation. Now, anytime I can factor, that's always going to be my first choice. And I look here and I have 4 terms. And I see that I can factor a -4 out of the second 2 terms. And that leaves me with an x minus 5. And if I factor an x squared out of the first 2 terms, I'm also left with x minus 5. So now I can factor an x minus 5 out of both of those terms, and I'm left with an x squared minus 4. And then finally, I see I have a difference of squares. So I have x minus 2, x plus 2. And then applying our zero product property, we take each factor and set it equal to 0. And we find our 3 roots or 3 zeros, 5, 2, and -2. And we knew we'd have 3 because the degree is 3. Okay, when I look at our next problem, I see I don't think I can factor this. So now I'm going to turn to the rational root theorem. And so I look at what is my constant term, which we're going to call a, and that's 1. We look at the leading coefficient is a, that's 1. The constant term b is 6. Now we have to find the integer factors. So for a, it's just plus or minus 1. For 6, we have plus or minus 1, 2, 3, and 6. So now that tells me that my possible, I'll just abbreviate RR for rational roots, are the integer factors of the constant term divided by the integer factors of the leading coefficient. So since it's all over 1, we're left with plus or minus 1, 2, 3, and 6. Now that doesn't mean that any of these are roots, because this could have all irrational, or you'll learn later that there's a possible combination of imaginary roots, which we'll get to later on in the unit. So I'm going to test 1 to start. I'm going to use synthetic division. And so going across, we have 1, -2, -5, and 6. And if our remainder is 0, then according to our remainder theorem, 1 would be a root. And then x minus 1 would be a factor. So doing our synthetic, multiply, and then we add, multiply, add, multiply, add. There's our remainder. So sure enough, x minus 1 is a factor, 1 is a root. So now I know that this third degree can be written as the product of x minus 1, and then our quotient here would be x squared minus x minus 6. Right, going across, we had x cubed, x squared, x to the first, and then our constant term. Each one of these will be 1 degree less than in our dividend. And I could try synthetic division again with another number, but I'm down to a quadratic. And so again, if I can factor, I will. And so this is factors to x, whoops, not x squared, but x minus 3 and x plus 2. So now I set it equal to 0 to find the roots. Using the zero product property, we take each factor, set it equal to 0, and we get 1, 3, and -2 as our 3 roots here. Okay, let's look at a couple of more problems. We're going to go to a little bit of a higher degree here. So again, we're finding our roots or zeros. And so I'm familiar with this format, and I know that if this was x squared minus 14x plus 40, that I could factor this, because I'm looking for 2 numbers that add up to -14 and multiply to +40. and that's negative 4 and negative 10. So I'd have x minus 4, x minus 10. Well, this format here with the x to the fourth minus 14x squared is very similar to that. So what I would have here, instead of x, would be x squared minus 4 and x squared minus 10. I do have a difference of squares here, x minus 2, x plus 2. And there's a couple of ways to deal with that. For now, I'll leave it like that. In our next unit, we'll talk about writing that as a product of two linear factors. So I take now each factor, set it equal to 0 using our zero product property. Right, I get 2, negative 2, oops. So I get 10, take the square root, absolute value of x equals root 10, x equals plus or minus root 10. So there's 2, 3, 4, and we have a fourth degree, 4 roots, all real, 2 rational, 2 irrational. Whoop, we got a little freeze here.